In this lesson, we're going to look at SQL or SQL. We're going to have a look how we can interpret it and modify the code. These are the key words that you should understand already. Your first question is, what is an ERD? Try and write the answer down now. It is an entity relationship diagram. Can you spot on here two different ways of capturing data? Hopefully you should be able to spot OMR and OCR, optical mark reader and optical character reader. Let's have a quick recap about what a database is. A database is a collection of tables that store data. Most companies that we come into contact with will have some form of database. So we need to be able to write and create databases. Think about when you go into a shop. They might scan a product. That will keep a record of their stock. It will have a list of prices so it can create a total for the customer and then charge the customer and sort the money out. Often a database system is called a DBMS. We have a DBMS in school, which is the system we use to take the registers. It's important for this lesson that you understand the key terminology for a table. We have a table which is the whole collection of data, the data that relates to an entity. For example, one entity, a student. A record. A record is related data, a collection of data about a single entity, such as a student. You can have many of these entities within the table. We have a field, which is a unique piece of data about an entity, such as a surname. And a field name. This is our label or our identifier for a single piece of data. Remember that to search a database, we would use a query. This allows us to search for specific data that might be useful for us in our database. So we're going to be learning about this structured query language, SQL. Now remember, query is a database search, so this is a language that can help us to return data from a database. There are several different SQL statements we could use, such as create table, select, update, delete and insert info. Please add these into your notes now. Now the first thing we probably want to do when setting up a database is create a series of tables. To do that, we start our SQL statement with create table. You'll notice this is all in capital letters, and you can see the example on the bottom of the page. Then inside the brackets, we put all the different fields that we want to use. Each field should have a name. This should be unique. Just like we do with variables in Python or in a programming language, we need to make sure that there are no spaces between the names. So we can use one of the case structures. You can see after the name of the data type, we have a actual data type. So for example, integer or text. Notice in this instance, you can either use integer in capital letters or int. A string is known as text. And the final one is the primary key. Remember, in a table, which is normalized in first normal form, we should have a primary key. You can see we've identified the student ID as the primary key in this example, and we've put that in capitals after the data type. So remember that we must have a data type and a primary key for each field when we're creating a table. Once you've created a table, it's probable that you want to insert some data into that table. Now there are some tools that will let you import a large amount of data. You could use the SQLite browser on our computers to do this. To insert into a table, we basically start with the keywords insert into. We then use the table name, and this must be exactly the same as the table name we've just created, including the case, such as a capital S here. We then put values after that, and inside the brackets, insert the values that we want to go inside the table. Now at the end of each line, we usually would have a semicolon, but some versions of SQL don't need a semicolon at the end of each line. There are other ways that we can insert data directly into certain fields and leave fields blank. Once we've inserted data, we probably want to select data from the table, and this is our first query. We use this select statement to get particular data. For example, select first name from students, and this would return for us the list of all the first names. We can return more than one field. If you look at example 2, there's a comma between the first data type or the field and the second one. So in this example, we're returning first name and surname from students. We can actually return a whole table. This is using our wildcard. We can know that as an asterisk. You can see in example 3, we put select wildcard from students, and that would return the whole table. Task number 1 is to create a database in SQL. I want you to create me a table to sort students' details in our class. Have a look at the code, and this should help you to do this. You can use the link on the screen as an example of an SQL browser. Task number 2. Look for my file called syntax errors. There are a series of syntax errors. Can you fix them? Pause the video and try and complete that now. Now you should have found a series of syntax errors. Just be careful with the IDs. All IDs should be unique. Remember that every line needs a semicolon at the end, and between the different types of data when you're creating a table you need commas. Let's have a look at the where clause. Now it's useful to be able to select a certain field from a table, but there's probably instances where we only want a few values from that field. So we use what we call the where clause, and this goes hand in hand with our select. We start with select, and in this instance I'm going to select all fields from students using the asterisk. But in this instance we say where, and we use group equals 9AB. So you can see group equals 9AB is our selection, and it would produce the table you can see on the screen. Task 3, I want you to go back to your table that you created. Create a where clause to return all the students from a certain form. Let's now have a look at the update statement. There may be somebody in the table that you need to update their details for. This is where we can use the update. If you look in my example, we use update students, so we say the table that we're using, and then set surname equal to what you want to set it to, where first name equals Tess. Tess would now be updated in the table. Now just a note about this. Think about what the problem would be is if we have two people with the same first name. We need to be very careful when we're updating data values in a database, because we might overwrite two values. So in an example like this, a better example would be to update the student ID, or update set surname where student ID equals a number. This means there's going to be no irregularities in the data. Add to your program an update clause. See if you can update somebody's details in the table. The next statement we're going to look at is the delete statement. This does what it says on the tin, and it deletes a record from our database. You can see my example here. We put delete from students. So we tell it the table that we're deleting from first of all, and then we use the where clause, where first name equals Jim. But remember, this will delete the whole record. Just be aware, don't forget the from, because if you put delete students, this will delete the whole table. Try using the delete clause now in your program. Can you delete a record? And I want you to look at this table here. Try to answer all the questions. There's a couple of questions that you might have to be careful with when you're trying to use these. Think carefully about the queries that you're creating. You should now have answered all these questions. If you haven't done so, please go back, pause the video and complete the questions. It's important that you try and test your knowledge as we go through. So question 1, you needed to make a query which would output all students taking course F451. So we'd use select wildcard. We want to output all fields from the student details table, you can see up here, where course code equals F451. Now, there's two pieces of bad practice in this table. First of all, course code should really have an underline between the two names to make it one variable. And secondly, my answer on here, student details, that should all be capitals really, because we've called the table name student details as capitals at the top. Question 2, write a query which will output all male students born after 01/01/1980. But we only want the output to include the name, date of birth and tutor group fields. Now this time we use select, and instead of using the wildcard, we tell it which fields we want to see. So name, date of birth and tutor group. It's still from the same table, so we'd say from student details. And our where clause would have the date of birth, and we'd use our logical symbol to say greater than 01/01/1980. Look how we've used the logical clause and here. We can use and, or and not, where and equals gender equals male. I want you now to have a look at the answers for question 3 and 4. Question 3 says write a query which will remove all students from the tutor group FMC. Now this is fairly simple because we can say delete from student details using our where clause where tutor group equals FMC. For question 4, we can have to insert a student details. And again, we use insert into the table name, student details, and we put the values in that we want. Notice on this line, I've missed a bracket off at the end. The final question was a real challenge. There's a lot of information to dissect in this, and this is an example of one of the exam questions we might be faced with. First of all, we always start with our select when we're doing a query. So that's the best place to start. Because it says all fields, we can start with select and then our wildcard symbol. From student details should be fairly simple, and that's the table we're using. Now the challenging part comes when we've got to select certain course codes and tutor groups. So we're going to start with our where. We need to output just our courses F451 or G403. So we can write it exactly the same, where course code equals F451 or course code equals G403. Look how we've had to say or course code twice. We can't just say course code equals F451 or G403. We need to put the whole logic, just like we do in Python there again. Put that in brackets so that you can see that we do that as one clause. And tutor group equals FMC or tutor group equals GPA. Now the part we haven't done is the order by. Now we can order something in ascending or descending orders. Remember, if we're using ascending order, that would be from smallest to largest, or from A to Z, And descending, we'd use the code DSC with a capital D, would be from the largest to smallest, alternatively from Z to A. So in this instance, when we want to order in ascending order by date of birth, we'd use order by DOB ascending. Please add the order to your notes. Remember, we can order by ascending or descending, and look at the code that we've shown here. For task 7, I want you to work in pairs. Write an SQL statement and pass it to the other students to see if they can tell you what to do. Then, set the other students a challenge to write a select, delete or insert statement. You make it as complicated as you like by using the ascending or descending order, and ask them to give the output. We now need to think about a little bit more depth about how we query two tables. Going back to our previous lessons, you know that sometimes we have relational databases. If we have a series of tables, we might want to pull data from different tables. Now this is fairly simple, it follows the same structure, we just use the dot notation. For example, we've got two tables here, song and artist. We can say song.song title to select data from one table. Notice how we have the table name first, and then the dot, and then the field name. In the same way, we can have artist.artist name and song.music type. In our from, we need to list both of the tables that we want to query though. So in this instance, we've got song and artist. And even in our where clause, you're going to actually have to have song dot or artist dot. Now notice in the where clause we've got song.artistid equals artist.artistid. Now that is the same key. Now if we look at the song table, the artist ID is actually a foreign key within this table. But we know that an artist can have many songs. But we're going to say at this point a song can only have one artist. Obviously in reality that is not true. But in this instance we're going to say that. So you can see in this table here that we have got S1, our song has a song title, is by artist 1, which is Fred Bates, but also song 2 has the same artist name. Now this allows us to link these tables together so that we've got our foreign key in place. Remember that if we did have many artists having many songs and many songs could have many artists, this would be a many-to-many relationship. So we would need a junction table between this. But remember, for these examples we're just pretending that each song can only have one artist. Now if we look at what we've just done on the previous slide, there's an alternative way of linking the tables together so we've got that relationship, and that is using a join statement. Join is a way of specifying where to join the columns. So how are these tables related? You can see the code at the bottom follows a very similar structure. We have our select statement. We have song and artist and our dot notation. However, this time we say from song, join artist. So we're saying table 1, that's where it's coming from song. We're joining it to the artist table, and on is where we make that join. I think this sometimes makes it much easier and makes it more common sense for us because we can set that straight away rather than it being in a where clause. It makes our where clauses simpler, where song.musicType equals pop. We've removed that song.artistid equals artist.artistid from the where clause into its own join clause. I now want you to think about how we can use joins in practice. So you want to store the details of the courses that the students take in a database. Create an entity relationship diagram for this and then show me this before you continue. Once you've done that, I want you to create the other tables. Then practice with a join statement to return which courses students are studying. For task 9, I want you to use the information in these two tables and construct an SQL statement which will output the subject and teacher from the courses table for all students in the students details table who are taking F451 or G403. Make sure you also output the student number and the name. Pause the video now and try and write that statement. Let's have a look at the answer. First of all, we're going to have a look at the select row. We're going to have student underscore details, that's remember the table name, dot student number, or the student name. So that was the first piece of data we wanted. We do the same for name, but we also need this course subject. So we have course.subject and course.teacher. These are the two pieces of information that we wanted to print out. Now, in this instance, we've used the join statement. So we're saying from student details, join course on, and we find the foreign key in the table, which is our course code in the student table. Because we're saying from student details, we need to join using the foreign key in this table. So we say join course on student details dot course code equals course.course code. That, remember, should be the same. There's our relationship created. Then we can use our where statement to only return the F451 or G403 courses. So student details.course code equals F451 or student details.course code equals G403. Let's work through these two together. So first of all, we're writing an SQL statement to delete an entire course table. Now, have a look at the answers on the next page and I'll show you how to do this. We can use the drop code to drop our whole course. Can you see how here we've used drop course and that will delete the table? There's a couple of other examples here. We can drop parts of a database. So drop index name on table name. This is going to delete an index in a given table. And drop database name would delete an entire database. So if you've got a database called student, that was how we could drop a whole database of relational tables. Your final task is to complete the SQL murder mystery. Use the link on the screen to see if you can solve the crime. There is an entity relationship diagram that you might want to look at first to give you an understanding of the tables, and then you might also want to use the walkthrough to help you. Please now complete the exam questions linked to SQL. Once you've done that, mark them, make improvements and spot any gaps in your knowledge.